Okay, since we didn't have school yesterday, because of unfortunate events, I decided to record a video about geometric sequence, which is our next lesson. And so let's get straight into geometric sequence. Geometric sequence is quite similar to arithmetic, not very similar, but similar in a way that, let me just give an example. If I start with 1, and then it goes to 2, and then 4, 8, 16, 32, and so on, you can sort of see a pattern that each term is multiplied by a common ratio. Now, in arithmetic sequence, it is just the same adding or subtracting. We're adding the same number every single time. But in geometric sequence, instead of adding, this time we're multiplying by a common ratio. So this one is just times 2, and this is times 2, this is times 2, times 2, times 2, and so on. Okay, so if we want to look at the general formula of a geometric sequence, we start off with the first term, which is a again. So let's say t of n, the nth term, okay, will be the first term, which is a, and then we're gonna multiply it by some common ratio r. So this will be our ratio r. This is our first term a, okay, and then that's just going to be a to the power r, okay, to the power of some number. Okay, so let's look at what goes in here in our exponent. If we look at t1, okay, that's our first term, that's just 1, which is the same as 1 times 2 to the power 0, okay? And then t of 2, that's the second term, that's equal to 2, is the same as 1 times 2 to the power 1. And then term 3 is 4, which is the same as 1 times 2 squared. And you can see it starts off at 0, and then it goes to 1, and then it goes to 2, okay? So if term is 1, the power is 0, so this is n minus 1. Okay, and this is just the general formula of a geometric sequence. It's similar to arithmetic sequence, but instead of add, this is multiply. Now, this r can be anything. It can be any real number. In fact, it can be 1, it can be 2, it can be 3, it can be negative, it can be half, it can be a decimal. So let's say, for example, I have a ratio of negative half. Okay, just an example. And so if I start at 64 is my first term. So let's say a is 64, that's my first term. So my sequence will be, first is t of 1 is just 64 times itself, times 1 is just 64, and then t2 is 64 multiplied by 0, negative 0.5 to the power 1, which is negative 32 in fact. And then if we look at t3, that's going to be 64 multiplied by negative half to the power 2, okay? And what that is just 64 times negative times negative is positive. That's 0.25, which is a quarter, which is in fact just half of 32, which is 16. And then if we go on, we can sort of see a pattern. T of 4 should be negative 8, t of 5 is 4, t of 6 is negative 2. And if I write it all out nicely, our sequence will be 64, negative 32, 16, negative 8, 4, negative 2, and then if we continue, it will be 1, and then negative half, and so on. Okay, we can already see that each term has an alternating sign. Okay, sign as in the whether it's positive or negative. So 1 is positive, this is positive, this is negative, this is positive, this is negative, this is positive, this is negative. And the reason that happens is every single time we are multiplying by negative something. Okay, so when we multiply a negative by negative, it becomes positive. And if we multiply a positive by negative, it becomes negative. Okay, so that is just a general form, using our general form. I have here at the bottom some example questions of geometric sequences. I will go through some of them, and then I will want you to try the rest of them on your own. So you might want to copy this on a piece of paper and then try to do some of the questions here. Okay. I'm gonna go ahead and do the first A1 and C. Okay, whoops, I just blocked the question. I'll do A and I'll do C. So if you want to go ahead and pause this video and try your best to do A and C first, then I will give out the solution in a brief moment. Okay, so I assumed you have done the question already. So if we look at A and look at C, how do we determine that common ratio? Okay, so we know that every single subsequent term is multiplied by a common ratio. Okay, it is the same times r times r. The first question is quite simple. We can see that it is 3, it multiplied by 3. But let's say the terms are not as easy to find. How do I find it? Well, I can take one term and I just have to divide it by the previous term, and I'll be able to find the ratio. All I have to do is divide. Okay, so if I do 297, the ratio is equal to 297 divided by 99, or I can do 99 and 3. You will find out that that ratio is 3. Okay, and then now we look at the first term, which is 11. So A is 11. Then I have the two things that I need to do my general formula. So T of n, I can write down T of n is equal to first term 11 multiplied by r, which is 3 to the power of n minus 1. So I have my general formula here. This is A done. Okay. Now let's look at C. Now this one you might be able to see it straight away. If you cannot see what the ratio straight away, just take any term and divide it by its previous term. Okay, so let's do that. Let me draw a line over here. So r should be equal to 4 over 3. That's this term. I'm going to take this term and I'm going to divide it by 2 over 3, which is the previous term. Okay, divide. Okay, that's to find r. 2 multiplies inside times inside, outside times outside. Bring them all to the top. So that means r is equal to 4 times 3 all over 3 times 2. The 3 and the 3 will cancel out. That's just 4 over 2. So r is equal to 2. Every single time it multiplies by 2. Okay? And the first term is 1 over 3. So, oh, what just happened there? If A is equal to 1 over 3, so T of n is just 1 over 3 multiplied by 2 to the power n minus 1. That's it. Okay? Or you can leave that as it is. Let's do one more. Let's do D as well, because D seems kind of complicated. Okay. Let me make a little bit. Yeah. Let's do D as well. So how do I find that ratio for D? Again, I'm going to take one term and I'm going to divide it by its previous term. Okay. So R is equal to 0.08 divided by 0.2. Okay, if you use a calculator, I don't have a calculator here, so I'll just multiply top and bottom by 10 first. So move that decimal and move that decimal. That's 0.8 over 2, which is 0.4. That common ratio, like I said before, it could be a decimal. Okay, so that's our r, and so our t of n is the first term, which is 0.5, multiplied by 0.4 to the power of n minus 1. Okay, so that's the first question. Now let's look at the second question. I will do. Should I do all of them? I'll do all of them. So, this one, we want to write the first 4 terms of each geometric sequence. Well, if we want to find out the first 4 terms, first of all, we still have to find out that general formula. We want to find out what t of n is equal to. Okay, we're given t of 1, which is the same as a, but we are, and this one we're given r, so this one is very simple. Okay, this one is very simple. T of n is equal to 7 times, put it in a bracket if it's negative, negative 3 to the power n minus 1. Okay, then next what we do is find the first 4 terms. T of 1 is just 7, okay, and then t of 2 is you multiply that by negative 3. That's the common ratio. So 7 times negative 3 is negative 21, and then negative 21 times negative 3 becomes positive this time, 63, and then 63 times negative 3 becomes negative 189. Okay, hopefully I did my mental math correct. Second question is very similar, so I'm going to skip B. Okay, and then C, it tells you the general form already. Okay, it tells you the general form. So all we have to do is substitute in those numbers. T of 1 is equal to 3, and then T of 2 is 3 times 0.6. And then if you use a calculator, let me quickly get out a calculator. 3 times 0.6 is 1.8, and then T of 3 is 1.8 times 0.6, so multiply by 0.6 again, and you'll get 1.08, and then 1.08 times 0.6 again, times 0.6, 1.08 times 0.6 is 0.636. Okay, so this one's very simple because they give you the general formula already. Okay, so I'm going to skip that. Let's jump straight to question 3. Okay, determine the number of terms. We want to find out what n is. We don't know what n is. They give you the first 3 terms, and then they give you one big number at the end, or one random number. So how do I know what n is? How do I know what the nth term is? Okay, so again, we have to determine the general formula first. Okay, we have to find out what t of n is equal to. So before I move on to the answer, I want you to try this on your own. I assume you've done the question already. Pause the video, do it, and then I will go through the answer. So A, the first term is 4, I know that. And then the ratio from 4 to 12, I know that it is multiplied by 3 because this one's quite easy. Okay, so R is 3. So T of n is equal to 4 times 3 to the power n minus 1. So that's our general form. Okay, now we want to find out what n is in this term. Okay, so T of that nth term is 78,732 is equal to 4 times 3 to the power of n minus 1. And then we can do a little bit of algebra, move that 4 to the bottom. 3 to the power n minus 1 is equal to, what's 78,732 divided by 4, that's 19,683. Okay, so we then need to find out 3 to the power of something, okay, is equal to 19,683. Now, there are some ways of doing this, okay? If you've learned how to use logarithms, okay, then you can use logarithms. Hopefully you have learned logs before. I'm not sure, but I will just show you how to do it. So what we can do straight away is take a log of both sides. So if I do log of 3 to the power n minus 1 is equal to log of 19,683. And then what that will enable us to do is throw, whoops, let me go away. There. That will enable us to move that n minus 1 to the bottom there. That becomes n minus 1 log of 3 is equal to log 19,683 over log of 3. And then you move that down, okay, to have to the bottom as algebra. So we will have n minus 1 is equal to log 19,683 over log of 3. And then you can just put it into your calculators. I'm not sure whether my calculator has it because I'm using my phone right now. Oh, I do. Log, wait. Do I bracket? Okay. Log of 19,683 log of that divided by log of 3 is 9. Okay, so n minus 1, n minus 1 is equal to 9. It will be much easier with your graphics calculator or your scientific calculator. So that means n is equal to 10 there. Okay, now if you don't know how to use log, then what you can do is just keep trial and error. Okay, we know that the first term was 4, then you just put into your calculator 4 to the power of, just keep going up until you get 78,732. So we determine that n is equal to 10. Let's do one more. I'll leave this here for a second so that you can copy it down. You can pause the video, and once you're done, I will erase all of that. Okay, let's do one more question. Okay, let's do B. Okay, it seems complicated. We always like to try complicated questions. So we're given the first term, a is equal to 5 root 2. We want to determine what r is. So 5 root 2 times something is 10. Okay, so r is equal to 10 over 5 root 2. Okay, that term divided by the first term, you get the ratio. Okay, 10 over 2 is just 2. 2 over root 2, rationalize it. Okay, times root 2 times root 2. So that becomes 2 root 2 over 2. And then that cancels out. It's just root 2, right? Did I do things right? Yeah, I did. Yeah. So it's just root 2. Root 2 over 2 is... 2 over root 2 is the same as root 2. So the ratio is square root of 2. Yeah, that's right. Good. Now, we know that t of n is 5 root 2 multiplied by root 2 to the power of n minus 1. To the power of n minus 1. Okay? And then we want to figure out what 640 is. Okay? What term that is. So we put that in. 640 is equal to 5 root 2 times root 2 to the power of n minus 1. And then I would bring this over down to the bottom, divide that. So that becomes root 2 to the power n minus 1 is equal to 640 divided by 5 root 2. Simplify things a little bit first. 640 divided by 5 is 128. Okay, and so 128, let's rationalize it because I don't like radicals at the bottom. So times root 2 over root 2 that becomes equal to n minus 1 root 2 to the power n minus 1, don't forget that, is equal to 128 root 2 all over 2. And so 128 divided by 2 is 64 root 2. Okay, I'm just going to clean that up first. That's 64 root 2. And then the same as last time, I'm going to use my logarithms. So log of root 2 to the power n minus 1 is equal to log of 64 root 2. And then you can bring your n minus 1 down. N minus 1 is equal to log of 64 root 2 all over log of root 2. And then you enter into your calculators what the answer is. Hopefully I'll be able to do this because I'm just using my phone, which is not very great for finding logarithms. Let's see. 64. Okay, how do I do this? Square root 2 root, where's square root on this? Okay, root 2 times 64, and then I need to log it, and then I need to divide it by bracket root 2. Oh no, I messed it up. Oh, I can't find it on my phone, but you can use your calculators and do that. Okay, I don't have my calculator with me at home right now, so I can't do it. Okay, so once you found out what this number is, then you add 1 and you'll be able to find what n is. Okay, okay, let's look at this one. Determine the number of terms in, let's skip this now. Let's do this. Now, suppose you are given one term and another term. How do I find what the other terms are? Okay, so this one, we're given a, but we don't know, what that number is, so I can't really know what r is. So we need to find out what r is based on the general form. Okay, so this, we know that if this is the first term, this is the second term, this is the third term, and this is the fourth term, so that will be t of 4. So t of 4, I'm going to write that down straight away, which is 6174 is equal to the first term times some r, which we don't know, to the power of 4 minus 1. Okay, so that's I'm just putting this into the general form, and then to find r. Okay, this is what we want. We want to find r. And then I'm going to divide both sides by bring the 18 down to the bottom. So r to the power of 4 minus 1 is 3 is equal to 6,174 divided by 18, which is, it's not a nice number. 6,174 divided by 18. No, it is 343. Okay, and then all we have to do is cube root that, and then we'll get 7. Okay, so r is equal to 7. So that's the ratio. Determine the unknown terms. Okay, so once we figure out the ratio, all we have to do is multiply by 7 and multiply by 7. So 18 times 7. 18 times 7 is 126. Okay, and then times that by 7 again, that's 882. Or you can write down T2 is equal to 126 and T3 is equal to 882. Okay, so that's A. Now, this time, we're not given the first term. We're only given the second term and the fifth term. Okay, so what I'm going to do here, I'm not going to use the general term. I'm just going to use a little bit of the meaning of geometric sequence. So what this is, for essentially it multiplied by r once, not 2, multiplied by r, and then it multiplied by r again to get 108. Okay, so basically 4 times r squared is equal to 108. Does that make sense? Oh, no. It needs to do it one more time, okay? So times r times r times r, so that's cubed is 108. So r cubed is equal to 108 divided by 4, which is 27. And so r is equal to 3, right? 3 times 3 times 3 is 27, okay? So we found out what r is. Then all we have to do is work things forward and then work things backward as well. So 4 times 3 is 12. 12 times 3 is 36. And you can check whether 36 times 3 is 108. Yes, it is. And then when we work it backwards, 4 divided by 3. 4 divided by 3. We'll get 4 over 3. Leave it as a fraction as it is, and that will be fine. Okay. Next, this one is times r times r times r and times r. It's 4 times. So 5 times r to the power of 4 is equal to 80. R to the power of 4 is 80 divided by 5, which is 16. And so r is equal to 2. Okay? 2 times 2 times 2 times 2 is 16. Yeah? So then you just do times 2, 10, 20, 40, and then 80. Okay? So I think I will leave this here. Should I do one more example? Okay, I'll do one question from question 7 here. Let's do negatives. Okay, B. This one is more complicated. Last one. Okay, so if I'm given T3 and T6, okay, I have to determine what the first term is and what the common ratio is. Okay, so essentially from T3 to T6, T3, and then there's T4, there's T5, and then T6. Okay, we have this given and we have this given. Okay, so we're only missing these. What happened is that multiplied by r, that multiplied by r, that multiplied by r as well. So it's r to the power 3, r cubed. Okay, so I'm going to put that down, write that down. Negative 1728 times r cubed is equal to 373,248. Okay, and so we have r cubed is equal to, divide that by negative 1728. So 373,248 divided by 1728 is negative 216. Okay, r cubed is negative 216, and then you take the cube root. It is r is equal to negative 6. Okay, so we've determined what r is. Then all we have to do is find the first term. Okay, so I can, from T3, I can go backwards to T2, go backwards to T1, or you can use the general form if you want. T of n is equal to a times negative 6 to the power of, let's put T3, okay? T3 is equal to a times negative 6 to the power of 3 minus 1, which is 2. And T3 is equal to negative 1728. Okay, I'm just substituting this into our formula to find A, essentially. So A is equal to negative 1728 divided by 36. So put that into your calculators. 1728 divided by 36. You would get A is equal to negative 48. Okay, so it says determine the first term, the common ratio, and an expression for the general term. So A is equal to negative 48. R is equal to negative 6. So T of n is equal to, I'm running out of space here, negative 48 times bracket negative 6 to the power n minus 1. Okay, so that is geometric sequence. Hope you guys understand. And next time I see you, which is tomorrow, hopefully I see you guys tomorrow. We'll do some practice questions on the arithmetic sequences and series, and also we might have to also continue on with the geometric growth and decay. Okay,